This is Murthy. Welcome to Raghav Math e-learning. In today's video, we would be discussing how to find domain of a function which is having step function. Already I have done 3 videos on domains. In one video, I explained what is concept of domain and how to find domain for the basic functions. And in one video, I explained how to find domain for the functions which are having logarithmic functions. And in one video, I explained how to find domain within 1 minute time using verification method for competitive exams. I gave all the links in description. Once you go through those videos, then you can get the clarity about how to find domain of the function and what is domain of the function. So coming to this class, here we are going to find domain of 1 by step x minus 2, is it? See, it is like a rational function. I mean, even the denominator is not a polynomial. Here we have some denominator, is it? So where this is defined, where this is not defined. So this is not defined. This is not defined when denominator is 0, is it? So that is step x minus 2 equal to 0. So step x minus 2 equal to 0 means step x equal to 2, is it? You know that when step x is 2, so x belongs to closed interval 2 comma open interval 3, then step x become what? Step x become 2. You know about step x. So step x is greatest integer. Step x is greatest integer less than or equal to x, is it? So you know step 2 point something, that is 2 only, is it? And step 2, that is also 2, is it? So step x is 2 if x belongs to closed interval 2 open interval 3, is it? So coming to this function, where this is not defined, if x belongs to closed interval 2 comma open interval 3, this function is not defined. So domain of the function, you can take all real numbers except the values in this interval, is it? So r minus closed interval 2 comma open interval 3. This is domain of this function. See, coming to second problem, f of x equal to step sin x cos pi by step x minus 1, is it? So we know that step sin x is defined at everywhere, is it? Why? Because domain of sin x is entire real number set, is it? So step sin x is also defined for all x belongs to real number set. So it's not a problem. Here it is cos function. Actually cos is also defined at everywhere. But here the important thing is, see, in angle we have the denominator, that is step x minus 1. So where this is not defined, if this denominator is 0, then this function is not defined, is it? So here this is not defined. This is not defined when step x minus 1 is equal to 0. Okay. So if this denominator is 0, then this function is not defined, is it? See here, step x minus 1 0. When this value becomes 0, I mean, suppose I am taking x minus 1 is t. To avoid the confusion, I have taken this. Then this becomes step t is equal to 0. So step t 0 means if t value is from 0 to 1, then if it is 0 point something, that is 0, you know. If it is 0, then also 0, right? So can you tell what about values of t? Yes, t belongs to closed interval 0, open interval 1. But what is t? We have taken x minus 1 is t. So x minus 1 belongs to closed interval 0, open interval 1. We want x. So x belongs to add 1, then you can get closed 1 and open 2. Is it clear? So for these values of x, this function is not defined. So domain of the function, you can take all real numbers except the values from this interval. So r minus closed 1 comma 2. Moving to next, f of x equal to 1 by square root of step x minus x. Okay, see here, when it is defined, so you know that here square root is there in denominator, so this is defined. This is defined when step x minus x is only greater than 0. Is it? Why? Because this is in square root. So step x minus x must be greater than 0. Is it? So from this you can write step x is greater than x. Is it? So for what values of x? Step x is more than x. But what is definition of step x? What is definition of step x? Step x is greatest integer. Step x is greatest integer less than or equal to x. Is it? So step x is greatest integer less than or equal to x. Means, is step x less than or equal to x? Yes. So we have step x always less than or equal to x for all x belongs to real number set. But here what we want? We want the values of x where step x is more than x. So is it possible? No, it is impossible. Why? Because step x always an integer less than or equal to x. But here we got step x is greater than x. Is it? So there are no real values satisfying this condition. That's why domain of this function, that is null set. So domain of this function is empty set phi. Coming to this problem, f of x equal to root x minus step x. So you know that this is defined. This is defined when x minus step x greater than or equal to 0. Try to understand. Here I have taken only greater than 0, but here taken x minus step x greater than or equal to 0. Why? Because this is in numerator. So the expression in square root may be 0. Is it? So from this you can write x greater than or equal to step x. Is it? So x greater than or equal to step x means step x less than or equal to x. Is it? So we know that step x always less than or equal to x for all x belongs to R. So step x is what? It is greatest integer less than or equal to x. So for all real numbers, step x is less than or equal to x only. So here we got step x less than or equal to x. When it is possible? For all real numbers, it is possible. So x belongs to real number. So domain of this function is entire real number set. Coming to next, we have to find domain of the function 1 by square root of step x minus 3. Is it? So here in denominator we have square root. So you know that when it is defined, here it is defined when step x minus 3 is greater than 0. Is it? Yes. It is in square root and it is in denominator. So it is not 0. Is it right? So it must be greater than 0. That is step x minus 3 greater than 0. Then only this function is defined. Is it? So from this you can take step x is greater than 3. Is it? So step x greater than 3. We know one thing. Step x always integer. Is it? And here it is greater than 3. So greater than 3 means definitely step x starts from 4 or 5 or 6 and so on. Is it? Now can you tell the values of x? So x belongs to closed interval 4 to infinity. So domain of this function is closed interval 4 to infinity. Clear? Coming to this problem. 1 by square root of 2 minus step x. So again same concept. It is defined when 2 minus step x greater than 0. Is it? So from this I can take 2 greater than step x. Is it? So from this you can write step x less than 2. So step x is integer and less than 2. So step x may be minus 3, minus 2, minus 1, 0, 1. Is it? That's all. So step x values may be like this. So for what values of x we can get these values in place of step x. That is x belongs to minus infinity comma. So here we want 1 also. So even you take 1 point something, that gives what? 1. Is it? So x belongs to minus infinity comma open interval 2. So domain of this function is open interval minus infinity comma 2. Now we find domain of this function. So here this is defined. This is defined when step x square minus step x minus 2 is greater than 0. Suppose I am taking step x is t. Then what we get? That is t square minus t minus 2 greater than 0. So just you do factorization, you can get t square minus 2t plus t minus 2 greater than 0. Is it? So it is t into t minus 2 plus 1 into t minus 2 greater than 0, right? So it is what? T plus 1 into t minus 2 greater than 0. So from real line you can write the solution. So that is here we have taken real line and this is 0, you know. Here what values we got? One is minus 1 and other is 2. Is it? So totally we have 3 intervals. Is it? So between minus 1 and 2 we have 0. Once you put 0 in this, then you observe sign of this inequation. So if you take t0, here it is positive and this is negative. So positive into negative, it is negative. So minus. Change the sign alternatively, plus and plus. What we want? We want greater than 0, means positive. Is it? So t belongs to where it is positive, between minus infinity to minus 1 and 2 to infinity. Here no equal to sign, so we don't take closed interval. Is it? So it is open interval minus infinity to minus 1 union 2 to infinity. Is it? So these are the values of t, right? But what is t? That is step x. Is it? So this means what? T belongs to minus infinity to minus 1 means t less than minus 1 or t greater than 2. But what is t? It is step x. So step x less than minus 1 or step x more than 2. You know that step x is less than minus 1. Step x integer and less than minus 1. Step x is integer and less than minus 1. So step x values may be minus 2, minus 3 till minus infinity. Is it? So here when we can get these values in place of step x. So that is x belongs to minus infinity to minus 1. Is it? So if you take minus 1, then you can get step minus 1 is minus 1. But if you get minus 1.1, you know step minus 1.1 is minus 2. So till this you can take. So x belongs to open interval minus infinity comma minus 1. Coming to this, here we have step x is more than 2. So step x is more than 2 means step x integer and more than 2. So you can take 3, 4, 5 till infinity, is it? So what about x values? X belongs to, so when step x is 3, you can take x3 then 3 or 3 point something, it is 3, is it right? So it is closed 3 to infinity. So x belongs to closed 3 to infinity. Now can you tell what is domain of this function? So domain of this function is open minus infinity minus 1 union closed 3 to infinity. This is domain of given function. Coming to this, the function is log x minus step x. We have to find domain of this function. Here we have logarithm, is it right? So you know that for logarithm, whatever input we are taking, that should be greater than 0, is it? So this is defined when x minus step x greater than 0, is it? So from this I can take that x greater than step x, is it? So it is step x less than x. We know that step x always less than or equal to x for all real numbers, is it? So when step x is equal to x, if x is integer, then step x equal to x, is it? So if x belongs to z, then step x equal to x. Suppose if x is a real number other than integer, then you get only step x less than x. See here we got step x less than x. So can you tell what is domain of this function? You can take any real number which is not an integer. So domain of this function is r minus z. My dear students, I think you understood this concept. Share this video with your friends, subscribe to my channel, click the bell icon to get latest notifications. Thank you.